So our next section is 7.4, complex rational expressions. So really what we have is fractions inside of fractions, and we want to simplify it. So we just have one numerator and one denominator. So the first thing I want to do is look at all these little denominators. So there's 3 and the 4 and the 8 and the 6. So those are all our smaller denominators, and I want the least common denominator. So if we look at those numbers, the smallest number that all of them go into is 24. So what we're going to do is multiply every single term by 24. So that 1/3 is being multiplied by 24 over 1. And then the 3/4 is going to be multiplied by 24 over 1. Down the bottom, that 7/8 is being multiplied by 24 over 1. And then the 5/6 is also being multiplied by 24 over 1. So if I go back to look, 3 goes into 24 8 times, and we're left with 8 times 1, so that's where that 8 comes from. For the second term, 4 goes into 24 6 times, so I'm left with 3 times 6, and that's where that 18 comes in. We move down the bottom, 8 goes into 24 3 times, so 3 times 7, we get 21. And 6 goes into 24 4 times, so 5 times 4 gives us 20. Now I can just combine them. 8 plus 18 is 26. 21 minus 20 is 1. So this whole thing just simplifies to 26. So that's what we have to do. We have to look at each denominator, find out what our LCD is, and then multiply that LCD by every single term on the top and the bottom. Whether it's a fraction or not, we still have to multiply it through. So our first example here, we have a 2, a 3, an x, and another 2. So if I look at the 2 and the 3, that I know I need a 6 for. And then we also have an x. So my LCD is going to be 6x. So I'm going to have to multiply every single term by 6x. So I'm going to do 6x over 1 here, and 6 over 1 there. 6x over 1 here, and 6x over 1 there. So every single term is getting multiplied by it. And then I have to go through and simplify. So the reason we pick that is so we know that every single denominator is going to be able to go into it. So 2 goes into 6 3 times. I'm left with 3 times x times x. So that gives me 3x squared. Here, 3 goes into 6 twice. I have 2x times 2x. So that leaves me with 4x squared. On the bottom, the x's cancel each other out. So 6 times 1 is 6. And then lastly, I have 2 goes into 6 3 times. So I have x times 3x gives me 3x squared. I can combine like terms on the top. So I get 7x squared over 6 minus 3x squared. So again, we started off with something with fractions inside of fractions, and we're simplifying it in a way that we just have a polynomial on top and a polynomial on the bottom. So that's our goal. Looking at the next example, we have a denominator, a smaller denominator here of x, and then down the bottom, it's x squared. So I have to take the bigger power to get rid of it. So my LCD is going to be x squared. So I have to take every single term and multiply x squared. So if it was in a fraction form, I wrote it as x squared over 1 like I did for these two. This I just had a whole number, so I just multiplied by x squared. So x squared times 1 gives me x squared. And then here, this x will knock out one of these. So I get x squared plus x. On the bottom, x squared times 1, again, is x squared. And then the x squareds cancel each other out. So I have minus 1. This one can be factored. So I think I'm going to be able to simplify it. So I'm going to factor the numerator. I can take the GCF, right, the greatest common factor of x out. The bottom is the difference of two squares. So that's x minus 1 times x plus 1. So those match. So that simplifies to a 1. And my final answer is just x over x minus 1. For number 3, I have a 5, an a, and another 5. So my LCD is 5 times a. So I'm going to multiply every single term by 5a. So the first one, this 5 cancels with that one, so a times 1, I'm left with an a. Here the a's cancel, so 1 times 5. And then on the bottom, the 5's cancel, and I'm left with 5 minus a times a. Well, remember, these two are just opposite signs. The a is positive, it goes to negative. The 5 is negative, it goes to positive. So those simplify to a negative 1. So my final answer is negative 1 over a. Number 4, we have an x squared and an x for the smaller denominators. So my LCD has to be the greatest power, so it's x squared. So I have to multiply the top by x squared and each of these terms on the bottom by x squared. So on top, I'm left with x to the 4th. This x knocks out one of those, so I have x. And then the x squares cancel, so I have 2. So x to the 4th over x plus 2. Number 5, one denominator is x, the other one is x cubed. So my LCD is x to the 3rd power. So I'm going to multiply the top with x cubed over 1 and the bottom with x cubed over 1. So this x knocks out one of these, so that becomes 4 times x squared. And then on the bottom, the x cubes are gone, so I'm just left with a 2. Now that I can simplify further. 4 over 2. And so my final answer is just going to be 2x squared. And then number 6, we have 2a squared, 2b squared, a and b. So my LCD, I need that, take care of that 2, and then I'm going to take the greatest power. So a squared and b squared. So I'm going to multiply this by 2a squared, b squared over 1. And the other term. And then both terms on the bottom. So every single term had to be multiplied by that. So starting with this first position, the 2a squared knocks out the 2a squared, and I'm just left with b squared times 1, which is b squared, minus this 2b squared knocks out the 2 and the b squared, so I have minus a squared. Down the bottom, this a knocks out one of those a's, so I have 2ab squared times 5, so that gives me 10ab squared. Plus, the b knocks out one of these b's. 5 times 2 gives me 10a squared b. So, there's a lot going on there. I'm going to factor it. I have the difference of two perfect squares on top. So, b minus a times b plus a. I can take out a 10ab on the bottom. And then I'm left with a b there and an a there. So these two are the same. They simplify out. So my final is b minus a over 10ab.